So we're the finish operations which are about to return our object and then will be put on the map. So first we fetch a dependency from position matrix. So every part subsequent like torso, neck and so on, shoulders, arms, depend on position of some other part, which obviously main part is not dependent on anything. It is just clear x, y, y, z position. So here is the hard dependency in the form of array. So the result of this gonna looks like let's say I depend from 0, 3, 6, 7, and let's say it's a hand, so it is connected to forearm, to arm, to whatever kind of spine, and to main object. So main object is common in every other dependency, like it is chain, it is parent of all those chains. So this one is fetching dependency. Mostly for objects that are animation dependent, because detectors and camera can be shifted in other way. Then we are using load part position matrix by reference is same as for animation. This is exact same script. It is used every frame if object is active. So in case I'm in edit mode and I want to move by force any character or part or something, I can edit it, and in case it is not 0 everywhere, it's execute what I put there. Respawning some of the objects, for example characters, in case they fall off the map, they're respawning somewhere, so I don't need to restart game if they fall off. And stop falling, so inertia translation is stopped, reduced to 0 again, and falling cycles start again. So those are two exceptions. They're gonna be, for example, respawn is gonna be later on put in subsequent script. Later on, all the animated parts which are on the list of the animation are moved, turned, and so on, depend on the fetch array we prepared previously, and some other objects like detectors, which are excluded. Camera and detectors are excluded, are loaded here. They are not in the animation. They have their own functions, and every of them have some function how to put him in the XYZ word definition, when to update, if to update, and so on. Same is for camera. Camera have some other operators. So, but it is generally same way as any other part. Just camera takes some information about modification for camera. So if we are moving faster, camera stays a bit after the object. If we are turning, it is turning faster than an object. So it has some shifts. And of course, we can control the camera separately by right stick. So in case we are not using keyboard, just the pad, gamepad. So camera have its position dependent on something else, which is stored in the object. And every part, at the end is writing down its position matrix and returning some more information from this matrix, like those vectors that are not held there. They need to be extracted. This is working only in case we are changing textures. So this is exact same script for helpers and visible, just refer to different parts, and it's asking the name of the texture and returning a correct texture. Previously I was using some Z textures, they are not in use now. I can turn it back on, but this is kind of material instead of using UV. So they are calculated in some way. Later on we are loading variables. It is same script for all of them. So the visible, helper and collider. Copy. And this struct is doing same as texture, almost the same, just it's referring to scaling and transformation. I didn't use transformation for anything for now, but scaling is important. We're gonna see scaling in work during animations, because I can dynamically change the size of the objects. So most what it does, it's returning reference to VBUF by its name. And here we have list of all VBUFs used for all those objects. So the hand can look like shield, it's not a problem, just it's pointless, yeah, it's gonna look kind of stupid. And here is the scaling. The only exception is vertex buffer for arrow, which is a helper, and just because it looks weird if I scale it like any other vertex buffer, I just redraw this arrow to a given scale, so I'm making it longer and just a bit thicker. Otherwise they'll be very thick. And if type is a character, we're rotating all the vertex buffers, but in current stage I need only to rotate a collision vertex buffer. So previously I was rotating also helpers and this what we see on the screen, but currently it is not necessary to do this. It is done by shader, so it saved me a lot of calculations on CPU. Otherwise, if it is not a character, so mostly it is some static object, I rotate everything because I'm gonna use colliders, and I don't need to use shader to rotate it any longer because it's gonna be done just once at the beginning of the game, like it is just a game room. A skinning operation for characters. So if there is a skin set, it is copying the skin set and putting new scale and new part, and using same script as we can execute during the gameplay to switch part to some different vertex buffer if it exists. There are also some exception handlings and going out from the function in case something goes wrong. Later on, characters have to start their animation stages. The object doesn't have it on the basic format, so we are just adding some anim packs and anim stacks, where is the pause time and what kind of transformation is affected. Currently it is those what I showed previously, 001, so we are rotating only collider, and we're rotating it only at the end of the animation, because it makes no sense to rotate it anytime sooner. Maybe I'm gonna change it. I'm thinking a bit about it when there be some active objects that can interrupt animation, and then we returning. Depending if we use this function during gameplay or on the object, we have different return, because editor itself operate directly on the map, and all other stuff like I found the sword and I putting it on the right place of the sword is working directly on the object. So those functions can have different arguments. Then we lerp to the pose. In this case it's gonna be basic pose. We're reloading again this function, so move all the parts to the correct place for the pose, rotate all the vertex buffers, so in this case just the colliders, and here it is something for characters. We are calculating body measures, which are used for some other functions. So first we calculate length of all the parts. In case we scale them, they need to be recalculated. So different stride lengths that are dependent on length between hip and upper leg and lower leg and toes itself. So right and left stride can have different length, because we can make some monster from our character and some other things. This one is important. Usually this should be 30. It is the maximal degree from the gravity vector that people can comfortably walk up. Over this, it is not walking, it is kind of climbing or other type of activity. I just put it higher because my kid like to play it, and he likes to walk on the walls, and I'm not about to make animations like for now for different kind of activity just for the sake of different angles of the walls. 90 obviously will allow us to walk on the walls that are straight up, so 60 is good enough. How many idle states is important for the clock changing the current idle state animation, how fast we can rotate character in the idle state, same for the rotating in walking state, how we can speed up during walk. When it is full, we go to the jog. If we hold a correct button, which is also speeding up our character, so it makes a lot of sense in controls. How fast we can rotate in the jog, speeding up the jog, how good we are jumping, flat, up, so here we are jumping higher but not that far, and sideways not that far that from the flat position. So the character is detecting terrain in the front of him and work accordingly.